So welcome to the precision of solids part. In the precision of solids, here you are going to see 3D entities, basic entities of solid, how to draw the projection of solids by keeping in the first position, second position and third position as we saw in projection of planes. Similarly, it is extended to the projection of solids also. But here you are going to consider 3D entities to solve the problems. So this is step by step considering the basic entities how to solve the problem. So when you take any solid, there is two groups. One is the prism part, another one is the pyramid part. So if you take a prism part, here you can see the one thing what we can observe in the prism is the top and bottom face have got same structure, connected by the edges, so that they are going to have a connectivity. In case of pyramids, if you take, of pyramids, if you take, the base will be having the required shape, but all of them will be having slant triangular faces, which is going to connect to the common point called apex. So here, before solving the problem, you are supposed to see how many entities, how many faces are there, and you have to know the namings of each surface, how it is going to be added in the problem, how it is defined in the problem. Then only you will be able to have a clear view of how to solve the problem. Otherwise, to solve the problem without knowing the words, it is difficult to solve the problem. So here cylinder also you can see it has got two same faces. Cube also it has got 6 square faces, and if it is a tetrahedron, here you can see there are 4 triangular faces which is going to have the connectivity. So further, if you take a square prism, here you can see there are edges which has got the connectivity to faces. The square prism and the square pyramid, you can see that at the base it has got square, but in the pyramid there are slant triangular faces which is going to have a common apex. Cylinder and cone, once again it has got a circular shape at the base, but in the cylinder the top face it is another circle, but if it is a cone it has got sad generator which is going to have connectivity to common apex. So if you take a square prism, here it has got the edge of the base, corner of the base, a longer edge, rectangular face, top, base. All these wordings will be used in the problem to define to solve the problem. If it's a pyramid, different names has been assigned in the problem which you're supposed to know. If you take a square pyramid, base edge of the base, corner of the base, and base, like this is going to use to define the base. So slant edges are there, slant edge and triangular face. Slant edge is the inclined line, triangular face is the containing one of the edge. It will be a triangular face. So all the triangular faces connect to a common point called apex. It's a square pyramid. If it is a cylinder or cone, so the imaginary lines are the thin lines. What it is drawn, it is known as the generators. So in the cylinder or the cone, that it is told, generating the curved surface means there are generators to connect the cylinder or cone. So once again, to define a cylinder or the cone, the cylinder has got a base. When the cone has also got a base, which is the circle cone, it is connected to a common point called apex. So for this, if you pass a section plane, so the shape gets changed. It is called as the frustum of a cone or frustum of a cylinder. So if you pass the section to the different prisms and pyramids, it will be having other shapes. So here you can see, if you pass a section plane on the solid, the shape it will be, the base is the circle. When after passing the section plane, the shape it will be ellipse. When the circle also, if you pass the section plane at some inclination, you will be going to get ellipse. And if it is a square pyramid, if you pass the section there, you can see irregular shape of the square surface. So like this, you'll be able to get different entities after passing the section plane. So standing on HP and its base axis is perpendicular to HP and parallel to VP. Here you can see in the front view, the square shape is visible. If it is resting on HP on one of the point of the base circle, you can see axis is inclined to HP and parallel to VP. So lying on HP means lying on HP on one of the generator. Here the axis is inclined to HP and parallel to VP. So here standing on HP, resting on HP and lying on HP, three cases are discussed. So further, standing on VP, resting on VP, lying on HP will be discussed. So resting on HP, resting on VP, standing on the base, resting on VP where the axis is inclined to VP and parallel to HP. The first case, axis is perpendicular to VP and parallel to HP. Last is lying on VP. Here one of the generator, axis is inclined to VP and axis is inclined to VP and parallel to HP. So like this, you must be able to get the different views of the base circle when it is going to rest on HP and VP. So when you want to solve the problems in solids, assume solid standing on the plane with which it is making inclination. If it is inclined to HP, assume it standing on HP. If it is inclined to VP, assume it standing on VP. So its top view will be true shape of its base or top. If it is standing on VP, its front view will be true shape or base of the shape. So here solid, cone, cylinder, so different cases, resting on HP, resting on VP, here it is discussed. So these are the different cases of problems where we are going to discuss in detail. So problem number 1, 2, 3, 4, it is solid inclined to HP and VP. If it is problem 5 and 6, it is a cube and tetrahedron. If it is problem number 7, freely suspended problem with the side view. Problem number 8, it is case of cube, means cube considering the side view. Problem number 9, consider the true length with respect to HP and VP inclinations. The problem number 10 and 11, it is the case of composite solids where we are going to consider the auxiliary plane, and in case of the frustum, when we pass, how we are going to pass the auxiliary plane, how we are going to retain the shapes of different entities.